Hi there, this video is to help you determine what the charges on ions are from the formulas. So let's take a look at what AP will give you. You'll find this sheet in Google Classroom and you'll see that it's on the note sheet part. So if you want to print out your own, there you go, you got it. But let's take a look at these problems. Anytime that you're going to see something like the name on an AP test, you'll also be given the formula. AP does not expect you to go from the name to the formula by yourself. They'll always give you both, or at minimum they'll give you at least this formula part, which really is the most useful part of things. So what I want to do is recap the ion charges and then go through what the ion charges are for all of these. So to recap from your first year of chem, this column right here are the ones that have one valence electron, and what they would do is lose that valence electron. When you lose an electron, you have more protons than electrons, which means this is a 1 plus charge. You lost an electron, more protons means a 1 plus. This one has two valence electrons. You'll lose both of those, so that'll be a 2 plus charge. In the AP world, it's the plus sign always comes after the 1 when you're doing ion charges. I don't think they're going to get you for that if you do the plus first, but that's the technical rule. In the D block here, we know that they can do many different things, and that's what we're going to cover in the next video. But one you have to remember is zinc is always a 2 plus. The other one to remember is silver is always the 1 plus. The rest of them they'll have to give you more information, and I'll show you that in the practice problems. Then remember we got this zigzag line here, and it separates the metals from the nonmetals. The metals are always positively charged, the nonmetals are negatively charged. So this aluminum here is going to be your 3 plus. This column down here is a 3 plus, or it could be a little different, but you'll know when they give you more information. As for the negative parts, here's your noble gases. They have 8 valence electrons, so they don't lose nor gain. They don't really have an ion charge. Fluorine over here, and the chlorine and bromine, they have 7 valence electrons already, so they'd want to gain 1. Gaining 1 valence electron, 1 more would be a 1 minus charge. Oxygen's your 2 minus group, 3 minus. In this column here, these ones here will be your 4 minus, and the ones down here will be your 4 plus, possibly, but then they've got different things that they do too. Once again, we'll show that a little bit later. So the real columns to remember is aluminum on to the left, and then your 3 minus through the 0 parts. This 4 minus 4 plus gets a little funny. Okay, let's go back to this part. So your job here is to find the charges for each ions. Like Na on the periodic table, it's in the first column, so it'd be a 1 plus. Cl will be your 1 minus, and that's all I'm looking for here. 1 plus and 1 minus. We'll do a K2O. K is also in that first column. It's an alkali metal. That's a 1 plus. Oxygen is in the 2 minus column. It can gain 2 electrons to become octet happy. And if I look at the charges, 1 times the 2 makes a 2 plus, and that balances out my 2 minus. Things are looking pretty good. Let's go to a trickier one. Number 6. I'm going to write it over here to have more room. With this problem, we can see there's a polyatomic ion. In your first year of chem, you'd have your periodic table, and on the back of it, you'd actually have all the polyatomic ions with their charges. You do not get that in the AP world, but you can figure it out from here, so you don't have to go and memorize all those. Let's take a look. If you remember back to your naming, iron and this 2 tells you the charges. It tells you it's a 2 plus charge. It doesn't tell you how many irons you have, it tells you the charge. So this iron is a 2 plus. 2 plus times a 3. This is a plus 6 side, which means this has to be a minus 6 side. And the only way for that to work when you have 2 phosphates means this whole phosphate thing must be the 3 minus. Those are my ion charges, 2 plus and 3 minus. At this stage, you should be able to go through all of them. So if you're feeling pretty good at what I did so far, hit pause in the video and go on and do the worksheet by yourself. On the next part of the form, you'll see the answers. So it's really okay to just hit pause and not watch the rest of the video. But if you are a person who says, I think I need a little more help here, I wish Staub would do some more for me. Let me do a few more for you. That might be tricky. Here's magnesium. Here's sulfur. Magnesium is in the, if I look up here, magnesium's right here. He's a 2 plus. It's connected to a sulfur. Sulfur's right here. He's a 2 minus. 2 plus, 2 minus. Moving on to Ca3P2. Calcium is down here. He's also a 2 plus. Phosphorus is in a 3 minus land. 2 plus, 3 minus. That works out because there's 2 times a 3. That makes minus 6. 2 times a 3. That makes a plus 6. Let's take a look at this lithium one. I wanted to go do this one because most people find it tricky. If you're having a tough time deciding like where's the plus side and where's the minus side, I will give you the hint. that there's always one element that'll be the plus side. Every single time it's that first element that is the plus side. The only exception is this ammonium here. Ammonium is the only positive polyatomic ion that you'll have to worry about, and that is a +1 to match out this oxygen's 2-. So ammonium is that only weird one. And you'll figure out ammonium based on the fact that it's got that 2 there, and I know oxygen is a 2-. So every other one, it's just that front element is going to be the positive guy. So really you can kind of like chop it in half between its plus and minus side by doing that. So we'll look at this lithium. Lithium is a +1. It's in the first column, which means this whole thing is your polyatomic ion, and it has to be worth a -1. You will never chop it 3 times or 4 times. You're always going to chop it in half once, which is what I did here. You got one side, you got the other side. I hope this helps. You'll see the answer shortly.